Hello AP Calculus, I've got a third lesson for you over chain rule. It's really just me taking a problem set from a different pool and seeing if we can learn some new things by going over a few of those. So, there's not a whole lot of new things you're going to see in this video, but it might prove helpful as you work through this third problem set on chain rule. So I've got 5 to go through. Number 17 is the first one. It looks like it's got some trig, chain rule, and like multiple parts of chain rule. So it might not be obvious what we're supposed to do here. Why don't you guys pause it and try it on your own? All right, let's see if it's correct. All right, the first thing I'm going to do is get that perspective by taking this whole quantity and make it to the 2 power. All right? Make sure you're not putting the 2 in the brackets. The 2 is being multiplied by secant squared. Order of operations dictates that powers come before multiplication. So you bring the 2 down when you take its derivative. That's going to be 2 times 2, which is 4. Rewrite this whole thing. So it's going to be secant of x to the 7 to the 1 power. Then we're going to multiply that quantity times the derivative of secant. So the derivative of secant is secant tangent. And then make sure you take the derivative of x to the 7. Which is 7x to the 6 power, just using a very simple power rule. Okay, so how should we write our final answer? Well, it looks like we've got secant squared of x to the 7 power. So 4 times secant squared of x to the 7. Oh, you know what? I should probably multiply 4 times 7x to the 6 and put that at the front end. 28x to the 6. Right, that makes a lot more sense. Then put the tangent at the tail end. And that's your answer for number 17. Let's check out number 23. You saw this one on a previous video, or something similar to it. Why don't you guys pause the video and try that one on your own? All right, you've unpaused it. You tried it on your own. I'm going to rewrite the root as a fractional power, because as you guys have gotten used to, roots just don't do well when you're talking derivatives. We've got product rule happening here. Rewrites in black, derivatives in red. So the derivative would equal first times the derivative of the second. So a half, bring it down, rewrite the middle, take one away, and then multiply by the derivative of negative 5 minus x squared, which is negative 2x. Plus the second times the derivative of the first, 2x. In purple, we'll factor out the smallest, or let's factor out what they share. Okay. So it appears that they both share a 5 minus x squared. You take out the smaller of the 2 powers, so that'd be the negative half. That completely gets rid of this part, reducing it down to 1. That takes 1/2 and subtracts negative 1/2, because that's what happens when you divide 2 powers of the same base. So this is now down to 1. Or I guess increases to 1. And then it seems like they both share an x. All right, so what I'm going to do is I'm going to factor that x out as well, which gets rid of it here and gets rid of it here. In the black brackets, let's write what remains. So you're left with negative 2 times a half, which is negative 1, times x squared. It's negative 1x squared. In the second part, you've got 2 times 5, which is plus 10, and then 2 times negative x squared, minus 2x squared. All right, that gives you x times negative 3x squared plus 10. And then you can divide that by 5 minus x squared to the 1/2 power. Or root 5 minus x squared. We should double check this one too, just to be safe. We're good. Let's talk 29 now. Oh my goodness. You have not seen this before. So 29. It's a trig function nested inside of a trig function. Dun dun dun. Oh boy. When the movie Inception came out, it was great because we were talking like trigception, everything, but nobody knows that movie anymore because we're all getting old. Now, as long as you understand function composition, this shouldn't be too mind-bending. We take the derivative of the outermost function, leaving, if it's trig, leaving its angle unchanged. The outer function is cosine. The derivative of cosine is negative sine. You must retain its angle. So it's the negative sine of cosine of x. Now multiply by the derivative of the inside. The derivative of cosine is negative sine, and its angle is just x. So its angle is just x. Kind of tricky, but kind of simple. Now here's where students will go wrong. They see two sines and they want to make it sine squared. Unless they have an identical angle inside the parentheses, unless those are the same, you can't call it a sine squared situation. So you can multiply the negatives together to create a positive, but it's going to be the sine of x times the sine of cosine of x. And you can't do anything more with it. That's it. So that was a little tricky. How about number 67? All right, sorry. The picture on this is slightly blurry. I'm not the greatest photographer. Please forgive me. Given the following table of values, find the indicated derivatives in part A and B. So for part A, they're saying g of x is equal to f of x to the third power. And they basically give you a table to find your values. It looks differently than what you saw from the textbook examples, but they're basically saying f of 2 equals 1, right? F prime of 2 equals 7. So you're free to write those out as they looked in previous situations to give yourself better perspective. F of 2 equals 1. F of 8 equals 5. F prime of 2 equals 7. F prime of 8 equals negative 3. I'm not saying you have to do this. I'm just saying make sure you recognize this is just a different vehicle in which to deliver information. A table is different than these equations. Same info. So they want g prime of 2. So I'm going to take the derivative of g. That means I need to put 3 down front, take away one of the powers, and then multiply by f prime. And instead of plugging in x's, I'm going to plug in 2. All right, go here. F of 2 is 1. That 2 is, it is what it is. F prime of 2 is 7. And this is all multiplication, so 42. Now this one is just to really illustrate the difference between cubing the entire function and just cubing the angle inside the function. So if h of x is f of x cubed, just the x, not the full thing, h prime is just going to be the derivative of f, whatever's put in place of, I call it the angle because that's what it is for trig, but it's kind of like the innermost function for any other. The innermost function has to be the same, right? The big error that students make is they'll call this f prime of 3x squared. They'll put 3x squared in parentheses, but that's not what's happening. You repeat it, then you multiply by its derivative, 3x squared. All right, plug in 2's wherever you see an x. So it's going to be f prime of 8, which is negative 3. I'll write it out so that our work is crystal clear about what's going on. I can multiply the 3 and the 2 squared. That's going to be 12. F prime of 8 is negative 3. Your answer? Negative 36. Okay. Now, last one, 71, I think would be very good for us to get on video here. Last one. And then you can bask in the gloriousness of having all of these videos for chain rule to help you guys out. All right, what's 71 saying? 71 is saying find f prime of x. If it's just f of g of x. All right, you know what? I think I want to go a little bit off to the side here. I need a clean space to do this. So capital F of x is equal to f of g of x. And they're asking us to take f prime of x, which I'm just going to do with the formula here. It's f prime of g of x times g prime of x. Okay? Now, we're told that f prime of x is x over x squared plus 1. We're also told that g of x equals root 3x minus 1. I'm going to call it 3x minus 1 to the half power. So it appears like I need to actually find the derivative of g at some point here. So I'm just going to do that right now. G prime is equal to 1/2, bring it down, repeat 3x minus 1, take 1 away from the half, then multiply by 3. Which is the same as 3 over 2 root 3x minus 1. All right, so f prime of x, that's like our outermost function here. We're plugging in g of x wherever we see an x. So it's sort of like, take this formula here and put a g of x in place of the x's. Hopefully that makes sense. Then you're multiplying by g prime, which is 3 over 2 root 3x minus 1. Because that's what g prime equals. And I need some more room, so I'm going to erase this. Hopefully that wasn't a mistake, erasing all that. So then, whatever g of x is, root 3x minus 1, I'm replacing it right now. Root 3x minus 1 goes in for g. Root 3x1 goes in for g. Squaring that, times 3 over 2 root 3x minus 1. So do you guys see that we can cross-cancel instantaneously the root 3x minus 1 and the root 3x minus 1 here? And we can square the square root here by just getting rid of the root itself. You've got 3x minus 1 now replacing this. So you've got 1 over 3x minus 1 plus 1 times 3 over 2. Then these are going to cancel. Negative 1 plus 1 is 0. So then you're left with 1 over 3x times 3 over 2. Cross cancel the 3's, and you got a final answer. 1 over 2x. And we've confirmed that that is a correct answer as well. And I forgot to confirm 67, but A equals 21 and B equals negative 36. Just rewind the video and make sure that's what we got. All right, video's 18.5 minutes. I'm done. Thanks for watching. Hopefully you enjoyed it. And that's it.